Okay, good guys. Today we're going to look at the accuracy of ProtaStructure, because I overheard some person saying ProtaStructure over design, some say ProtaStructure under design. So today let's really look at the accuracy of ProtaStructure. Now today we're going to use one of the example in Oyenoga Victor or Oyenoga textbook, which is a simplified reinforced concrete design, second edition. So we open the textbook and this question under the beam, the design of beam, which is beam design page 170. The first example there, which is example 6.1, which says simplify first beam. And the question is, a roof beam span 4.2 meter and is to be 450 mm by 230 mm in cross section. It supports a parapet wall 1.5 meter high, which in turn supports a lane to roof 4.0 meter wide. If the ultimate total load of the roof is 4.5 kilonewton per meter square, estimate the load on the beam and design the beam completely. Assume the beam is simply supported and designed to 250, which is this is the strength, concrete strength, and this is for the steel, characteristic strength of steel, yield steel, and assume weight of wall and finishes to be this. Now what we're going to do here, actually now they've calculated all the load and they have arrived at a total of 20.5 kilonewton per meter. Now this is the beam, the drawing. Now we're going to open our ProtaStructure and make this drawing. Now let's come to our ProtaStructure. We open new, let's call it example. Example 6.1. okay 6.1, and let's choose our BS code, because we are using the BS code version. After now we'll also move to the Euro code version and solve the same question. Okay, let's wait for our window to open, ProtaStructure to open. Okay. Now we have our ProtaStructure here. We're just going to go straight to modeling with big houses, with big grid, and we draw our houses. And this is the first house. This is labeled A. Now I'm going to copy it, use offset to 4.2, because that was what stated. I'm going to copy it to 4.2. okay, and draw to that one. Okay, and just change this one to 1, and that the other two are labeled A and B. Okay, now that we have, it's going to pick our column. Since we are using a beam of 230, our column should be 230 by 230. Place your column here, place your column here. Now we're going to draw our beam. Our beam, as it is given to us, is 230 beam by 450. draw our beam. Okay, now we have our beam. Let's open two windows so that we can also see the 3D and see the changes. Okay, now we have our 2D here and our 3D here. Now the primary thing we want to do here now is let's go to load. We have load, then you pick your beam. Let's load the beam. We are after the beam. We are not going to design the column. In another video we'll discuss column. We are not going to design column here, so we are just after the beam. Now let's go for the beam. I need to pick steel and concrete and okay. Now our edit load window will open. From here we're going to edit the load. Now the load will come with the self weight of the beam. Self weight of the beam, which is this 2.484. How do we arrive at this 2.484? Let me explain that to you. We have a beam of 230, which is 0.23 times 0.45, then times 24, which is the concrete unit weight of concrete. And if you press this in your calculator, 0.323 times 0.45 times 24, you're going to have exactly what we have here, which is 2.484. So that is how the ProtaStructure arrived at this value that is here. Okay, let's clean out all this. Let's clean this out. Now we've gotten our self weight and the total weight. If you look at the textbook, we have a total load of 20.5 kilonewton per meter. Now if we have a total load of this, how can we now remove this one? Because this self weight is also included. So we're going to do some simple mathematics here. Let's say we have x plus 2.484 times, because this one is also going to be times the factor of safety, which is all this together, times factor of safety, which is 1.4, is giving us 20.5. So we're going to get our x from this simple mathematics. Divide 20.5 by 4 point this and subtract 2.484 from your value, which means our x is going to be 20.5 divided by 1.4 minus 2.484. you do this in your calculator, divided by 1.4, we are having 40.643. So we're going to minus 2.484 on this. So our answer, our x finally is going to give us, 12.59 approximately. So this is going to be our additional dead load that we're going to include here. Okay, let's clean this out, please. Okay. Alright, so our additional dead load is what? 12 points. So we're going to come here, it's going to be a full uniform load. Click on full uniform load. It's going to be it's going to be labeled G2 because we are here. G2 don't have live load in this question, so we're not going to include Q. We are only going to concentrate on G, which is dead load. So we have G2 is labeling G2 because we have live self weight, which is already G1. So here is going to be gravity because it's coming down. Then here we have it as well, 12.159 approximately. Then you come and put it here, place it here. Now you have two load here. Now you click on this one, is the one we just put, and click on this is the self weight. Now you click OK. Now you have input your load successfully in this beam. Then the next thing you will do is, let's go to review and check our drawing. It's going to mark good, of course. So we have it as no error. So we have number of error 0. Then we are going to analyze this beam and design it. So go to building analysis. And when you come to building analysis, you just do this little configuration to set your beam reinforcement. We'll come here. This is beam, so we are concentrating on beam. What size of link are you going to use? I'm going to suggest 8 and 10. Then the beam, the reinforcement I will use, I'm not going to use 12, it's 13 because 13 is not in Nigeria. We don't have reinforcement 13 mm. So we are going to suggest 16 or 20 for the application to choose suitable one. Then you come and click your beam, and you come here. I'm removing this 8 and 10 from under the beam so that do not choose it because I have it here under link already. So you're going to click on that. I want to also remove 20 from link. I will not need 20 for link. So I click OK, you click OK again and OK again. Now you come to design, analyze, you analyze the structure. Now let's wait for it to come up, then you analyze. Don't forget, what we are looking at here is the accuracy of ProtaStructure compared to our manual design. Okay, now is building analysis completed successfully. Now command good, yes. So we can close this and close this. Now we have done our analysis. Let's go to design and design the beam. I told you we are focusing on the beam, not column. So our target is on beam. Let's go on this beam. Don't forget we have just one beam. That is why you are seeing only one beam in this place. Let's go to bash mode design. I'm going to put it this one. It's not going to choose outside what I've already selected. So is that going to be that 16 or 20? So let's wait for it to be completed. Now process completed. You can check your messages showing you here. Process completed. F story 1 reinforcement design. Now you can close this one, close this also, and let's look at what this design is actually giving to us. Now what we are having here now in this design is that we need 3y16 at 3y16 at the bottom and 2y16 at the top. Don't forget, we're definitely going to need some reinforcement, at least 2 to hold the steel up at the top, but we actually designed for the bottom, which is the tension zone. So now let's check our drawing and see how it's going to come up. Now before we do that, let's check the area required. Check okay, this one has come up. We need 3y16, and now this is how it's going to be detailed. 3y16 at the bottom. Okay, now let's close this window and go back to our textbook. Excuse me. Okay, now we have our textbook here. Look at what do we have at the design. We have 2y, so we should provide 2y20 at 2y20 at the bottom, which is giving us this. Now, and our design is giving us 3y20. Now let's do some comparison here. Out is giving us 3y16, and 1y16 is 201. Area of 1y16. If you want to know that, you can use this is the pi times half of the area, half of the diameter over 2 square. This is what you can use to get this area of a circle to get this. So it means you're going, okay, you can do that yourself. Now we have this times 3. We are going to have 603. Why our design is from the textbook, we are having 2y20, and 1y20 is 314. You can also use the same method, which is pi times 20 over 2 square. You can use this to get this, and now is 314 times 2. This is also going to give us what? 624. Now from the required, this is what, sorry, for the required, this is what is arrived at as what it requires. So if we use this one, we are still very much correct. So the ProtaStructure is still very much correct. As a matter of fact, this one is still more economical. ProtaStructure is still give us what is more economical, being that 3y16, the amount of 3y16 compared to 2y20, this will be more economical. Okay, So you can do this for some other example, and you're going to get the accuracy of, you can compare the value you get from the textbook and what you're going to get. Now don't forget, some of the value is going to be deeper for some area. For instance, for the total area required, let's check area required here. Here we are having area required as we have here 4 this. Okay, so I will like and subscribe to our channel, and more videos are coming up for us to compare and see the accuracy of our ProtaStructure and some other apps design that we can use in our design. Thank you.